Okay, so for the final exam, you're either going to have a second order differential equation that you're going to solve through matrices, or you're going to have a system. So on this particular exam, we have a system of differential equations that I went ahead and wrote it down as a matrix. So let's go through all the steps of finding the eigenvalues, the eigenvectors, and coefficients, okay? So, step one. Step one would be looking for the eigenvalues. Okay? So we're going to take the determinant of A minus lambda I. Okay, so that would equal the determinant of 1 minus lambda, that would be a 2, that would stay as a 3, and this would be 2 minus lambda. Alright, so that would equal now 1 minus lambda multiplied by 2 minus lambda, and then minus 6. Okay. So, well, 1 times 2 is just going to be 2. And then negative 2 lambda, negative 1 lambda, that would be a minus 3 lambda. And then plus lambda squared, minus 6. Okay. So that would come out to be lambda squared, minus 3 lambda, and then minus 4, because we have the 2 and the negative 6. Okay. Now let's go ahead and factor this thing. So, lambda squared minus 3 lambda minus 4, we know there's going to be a 4 and a 1. So that would be lambda minus 4, then multiplied by lambda plus 1, and we would set that equal to 0. Okay, so that tells me that lambda 1 is going to equal 4, and that lambda 2 is going to equal negative 1. Okay, great. Means we solved step 1. Okay, now let's go to step 2. Now step 2 is going to be the eigenvectors. Okay, so we're going to solve A minus lambda 1I, V1, and we're going to set it equal to 0. Okay. So we picked lambda 1 to be 4. So A minus lambda 1I would equal, okay, so this would be 1 minus 4, 2, 3, 2 minus 4. All right, so 1 minus 4 is negative 3. That's 2. That's 3. That's negative 2. Okay. And on all these problems, if you don't get it in a way that by taking the top row, you can eliminate the entire bottom row, you have the wrong eigenvalue. So that should be an immediate sign that you did something wrong at the beginning, okay? And to start the problem over. But on this one right here, what I can take the top row and just add it to the bottom row, and it cancels everything out. So, you know what? Since we can eliminate that row, let's divide this top row by negative 3. And we end up with 1, and then negative 2/3, 0, and 0. Okay, now this has to act upon some V1 and produce 0 and 0. Okay, so that tells me that my V1 is 2/3 and 1. Okay. Okay, so great, we got our first eigenvector. Now let's find our second eigenvector. So A minus, let's say, lambda 2I. What's that going to equal? So my lambda 2 was negative 1, so that's 1, and then minus negative 1, 2, 3, and 2 minus negative 1. Okay. So that ends up becoming 1 minus negative 1 is 2, that's 2, that's 3, and that guy's 3. Right, now by taking the top row and multiplying by negative 3 over 2 and adding it to the bottom row, we can completely kill off the bottom row. What can we also do to the top row? After we've eliminated, just go ahead and eliminate that bottom row. I could take that top row and I could divide that guy by 2. So what this would eventually come out to be is 1, 1, 0, 0. Now acting upon V2 is supposed to equal 0 and 0. Right? That tells me that my V2 is going to equal negative 1, 1. Okay. So, great. I got both of my eigenvalues, eigenvectors that are associated with the eigenvalues. Okay. Now that I've found my eigenvalues and my eigenvectors, I can look for the constants that are associated with the initial conditions of the problem. Okay. So step 3. Okay. We're going to find C1 and C2. Okay. So at this point of the problem, we have that x1, x2 is going to equal C1. Now, what was my first eigenvalue? Is e to the 4t. Okay. And that's going to be multiplied by 2/3 and 1. And then plus C2, this would be e to the minus t. Now multiplied by negative 1 and 1. Okay. So let's go back to the initial conditions of our problems. So we have that, where are we at? X1 of 0 is going to equal 4, and x2 of 0 is going to equal 1. All right. Now, when we plug 0 into this, the exponential functions just disappear because e to the 0 is just 1. Right? And so if I was going to form this into a matrix and try to find C1 and C2, what would this come out to? This would come out to 2/3, 1, negative 1, 1. Now acting upon C1 and C2, oh, sorry, I wrote the numbers backwards. That's 1, and that's 4. Excuse me. So I look back at the original beginning of my problem, x1 of 0 is 1, x2 of 0 is 4. Sorry about that. Okay, so that means that this thing is going to equal 1 and 4. Good. All right. Now let's go ahead and write this as an augmented matrix, so we're not writing the C1 and the C2 so many times. So that's 2/3, 1, negative 1, 1, augment, 1, and 4. All right. So let's take this top guy, let's multiply by negative 3 divided by 2 and add downwards. Okay, so that'd be 2/3, negative 1, 1. We're we're trying to get that to be a 0, so that's what we're trying to get to. All right, now negative 3 divided by 2 multiplied by negative 1. That's going to be a positive 3 divided by 2. Now, a positive 3 divided by 2 plus a 2 divided by 2 would be a 5 divided by 2. All right, now let's think about this one. This is going to be a negative 3 over 2 right here, and it's going to be added to a 4. All right, so what is another way to think about this problem is, what is it really? It's negative 3 over 2 plus 8 over 2. So let's think about that. Negative 3 over 2 plus 8 over 2, that's also 5 over 2. Okay, so then we can multiply by 2 divided by 5. And we'll get 2/3, negative 1, 0, 1, augment 1, 1. All right, now I'm just going to add upwards. So that would be 2/3, 0, 0, 1, augment 1, 2. Okay? And then I'm going to multiply by 3 divided by 2. Okay? So that's going to be 1, 0, 0, 1, augment 3, 1, like so. So C1 will equal 3, and C2 is going to be equal 1. So let's have a look at our answer. So x1, x2 is going to equal 3 times e to the 4t, now multiplied by, what was my vector? 2/3, 1. And then my second one was just 1, so that's plus e to minus t multiplied by negative 1 and 1. Okay. So this thing's going to come out to being 2 times e to the 4t minus e to the minus t, and 3 e to the 4t and plus e to the minus 2. Okay, so this is the solution that we got. Is it the correct solution? Well, let's ask ourselves, well, first question, does it satisfy the initial conditions of the problem? So if I plug 0 into this guy right here, I get 2 minus 1, it is 1. If I plug 0 into that right there, I get 3 plus 1, which is indeed 4. Okay, so the initial conditions are satisfied. All right, now let's check if it passes the derivative test. So, if I did the derivative with respect to time, okay, so when the derivative acts on it, it produces that. Now let's see what happens when the matrix acts on it. So we go back to our original matrix. One, 2, 3, 2, and let's have this guy act upon it. 2 e to the 4t minus e to the minus t, 3 e to the 4t plus e to the minus t. Okay. Now imagine 1, 2 acting upon this thing right here. Okay, so what's it going to do? It's going to multiply that guy by 2, and I mean this guy by that guy by 1, and this guy by 2. So that would be 2 e to the 4t, and that would be 6 e to the 4t, which would be 8 e to the 4t. Okay. Now 1, 2 acting upon these guys over here. So 1 acting upon the negative 1 is going to be negative. And then 2 acting upon the positive 1 is going to be positive 2. So a negative 1 and a positive 2 is going to turn that thing into positive. Okay. Now 3, 2 acting upon this guy right here. So we multiply 3 times 2 and 2 times 3. That's 6 plus 6, which is going to be 12. E to the 4t. Okay? And now you have to imagine 3, 2 acting upon these guys right here. So what's that going to give you? That's going to give you a negative 3 and a positive 2. So a negative 3 and a positive 2 is going to turn that into a negative 1. And so that's negative e to the minus t. Okay, so from this point, we can see that the operation of the derivative and the operation of the fundamental matrix produce the same thing. This is how you're double checking yourself, that the derivative and the fundamental matrix actually do produce the same thing, and that's when you know you actually have a correct solution to the problem.